Good day, students. Welcome to Social Science 5 class for today. My name is Benjamin Nathaniel, your tutor for Social Science 5. Right, we'll be together for the next more or less 30 minutes. Just a little bit introduction of the module, just to know that you are at the right place. You are here for Social Science 5. And this is really focusing on geography. So this is a more now not any longer a junior primary or upper primary level, but now this is a senior secondary level module. Right, you have this module has 14 credits, and that means that you also have 14 or 140 national hours. National hours just means that you have at least 10 hours for each credit, for each one credit. The prerequisite for this module is Social Science 4, and for that reason I'm not really going to touch more on the basic three units which you have been doing from Social Science 1 to Social Science 4 a module, things like understanding the rationale and pedagogies in teaching social science, a unit on lesson preparations, and a unit on assessment. I'm not saying that it's not part of your examinations whatsoever. You will be assessed on that, of course. Pay attention to it. But I'm saying for the purpose of time, we have only 30 minutes for this lesson. I'm not going to touch on those basic theories because for you to achieve Social Science 5, it means that you've done other Social Science 1 to 4, and we have been discussing those first three units for almost all the time. All right. Just a little bit on the structure of basic education. This is taken from the National Curriculum for Basic Education for 2010. Just that when it comes now to the structure of basic education before you get to higher education, you are prepared to reach at that level, the level of senior secondary. Social Science 1 to 5 deals with areas or modules which are much lower than that. To teach now upper primary or lower primary, that's been taken care of by the earlier versions of the social science courses we've been talking about. So this is Social Science 5, and the focus is more on senior secondary level. Make sure that the two children or the learners you are teaching now, you are preparing them either to go for tertiary studies or for vocational or sometimes for employment or even for self-employment. So this is a time now to teach students or learners to be self-independent, to be self-dependent, to do anything that they can get out. It's not necessary anymore to prepare them for a next grade, but at this time you can also prepare the learners to understand the whole socio-economic, even though this has more focus on geography. Learners generally at senior secondary level are being taught to understand the whole national priorities, engage. In fact, you as a learner first need to read documents of national priorities. When we say document of national priorities, we mean documents that help us to plan Vision 2030's national development goals or national NDPs or the Harambee Prosperity. We need to familiarize ourselves with these national documents because we need now to prepare students to go either way. Those who can go to tertiary can go, those who can go other routes can also go, especially now with the vocational training being given high priority at the national level. Okay, the assessment for this course, I understand probably most or all of you have already written an assignment that was marked a few weeks ago. So you wrote an assignment out of 130 marks, and you are expected to get 50% for you to be qualified for the upcoming exam. The upcoming exam is in August. Already start preparing as much as you can. and you are expected to write a 3-hour examination paper, for which also you need to get 50%. Now, understand that you need to get 50% first from the assignment, and then you need to get 50% from the 50% or more, let's not say 50%, and then you need to get that much from the exam, and then your final marks will be 60% of your exam. That means that 60% of the 50% you get from the exam, and then 40% of the 50% of whatever you get from the assignment. That will come up with the final marks. So for this lesson, I would just like to focus on a few things, especially based on the exam, on the assignment that you have written already, and also considering the exam that is coming up. So I would like to point out a few things that you really need to take care of, to prepare as you prepare for the course itself, but even much as you prepare for the upcoming exam. Like I said, I have skipped the first 3 units. Those are the first 3 units that we've been dealing with since Social Science 1. So I find it not so useful to delve on that at this moment, because we don't have much time. But I still have to reiterate that you need to pay attention to the first 3 units of your study guide, which the first one is the understanding the pedagogies in social science, and also going to preparation of lesson plans. You need to take note of this, and also assessment methods in social science. So we are not going to talk about them in this presentation, but the only thing that I should advise is that please revisit those first three units of your study guide. They are very important. Okay. The formation of the earth is the very important part of Social Science 5, which has a focus in geography. It's only after knowing how the earth was formed and how scientists and those early scholars tried to map the earth. The part of mapping, even if it's very important for this course, is not contained in this lesson, but still take note of the whole mapping concept in geography. There is no, I would say there's no sort of an exam that would come without any reference or anything that is something to do with mapping, because mapping is very central to geography. Okay, so this is an extract. What you can look at now on the main 3 components of the earth as you move in the depth direction. At this point in geography, also even here, when we are now dealing with the lithosphere, the part of the earth that you have to do something with below it, from the surface getting to the core or to the center. But you also need now to understand the relationship between the lithosphere, that what you are dealing with now, with the biosphere, which we're talking about now, the area of life that deals with the human or with life, animal, people, plants, stuff like that, and also the atmosphere. So the relationship between the lithosphere, the biosphere and the atmosphere, and also the hydrosphere, which has something to do with the water, oceans, and water vapor and all those things in the atmosphere. Those are the main 4 parts, or the main 4 systems. We call the earth a systems of system, which is now the lithosphere, the biosphere, the atmosphere, and the hydrosphere. At this moment, we are dealing at the lithosphere. We are dealing with the lithosphere. We are saying that as you move from the crust, where we are now, this is if you are somewhere in whatever you are on the earth's crust. This could be Windhoek, it doesn't matter. We are just saying that this is the earth crust. But now the diagram on your screen now, it says now take a cross section, because the earth we know that the Earth is spherical. It's not necessarily called a circle like a soccer ball, whatever, but it's spherical in a way that even if it have some rough edges or oceans and some lower elevation parts, we are still saying that it has that kind of spherical shape. Now if you take a cross section, if we have to make this point here, point A is the center of the Earth. Now we are saying if you are on the Earth surface, okay, now beyond the Earth surface, now you go to the atmosphere. This layer, from here we call it atmosphere. And beyond the atmosphere, that's when you move now to the space, or outer space, where the atmosphere have ended. The atmosphere is a layer which has impact mostly on the climate. We are saying that we're not talking about the atmosphere, and this is very important because I will not be referring to many of the things as we go ahead. As you look at the atmosphere, you start with the first layer, which is the troposphere. The troposphere extends only around 9-10 kilometers above the surface, and that's where most of the weather and climate events are being manifested. So beyond the atmosphere, where you reach beyond the troposphere, you have the tropopause, and then you go into the stratosphere, then you go to in the mesosphere, and then you go to the ionosphere, and all those other layers above the surface, where these layers are more important for astronomical studies, not necessarily anymore for the weather study. When you are talking about the weather and climate, we are concerned with the first 3 layers of the atmosphere. Primarily the first layer, which is the troposphere, and even better, the first 4 or 5 kilometers of the Earth from as you reach the Earth's surface, which you call the boundary layer. We say that most of the impact from the Earth's surface are being felt as you go 3 to 4 kilometers above the surface. Now let's leave that above the surface. Now we are going to say below the surface. Now as you move toward the center of the Earth, we are saying that the center of the Earth is where is the place, or is the space which determine the gravity that we have. So as you look at at 3b at the degree there, at the diagram here, that is the most center, the center part of the Earth. That's a cross section as you move from this Earth's surface, or from the crust. The crust is this layer which is under 1. So under 1A you have 1A and 1B. Now 1A is the oceanic crust, which is a very, very, very small layer, a thin layer, because as you know that the oceans are at a lower elevation of the crust. So that's why you have rivers are always flowing toward the ocean. I mean, you cannot have an ocean which is at the same level as the Earth's surface. Now you move, so the 1A here, we're talking about the oceanic crust, and you have to pay more attention to this, because you will need to understand why or how do these layers propagate from the topmost layer where we live, which consists of soil, primarily soil, even if we have some rocks, but we are saying that the topmost layer of the Earth consists of the soil, which is 1B here. So 1A is the oceanic crust, and 1B is the continental crust. The continental crust is where the continents are. We know that the continents are more or less just like ice blocks on the ocean. So the continents extends just around more or less, I would say the whole, say 10 kilometers, and the oceanic crust is much thinner than that. Okay. And that define 1A and 1B in your diagram that you are just looking at now. Then we go to the most deeper layer. Or think of the Earth as just as you look at a tree. The tree also, if you look at the tree like this, that's a tree. Now take a trunk, take a cross section from here. You have the center. So as you move from this side, from the bark toward the heartwood, the center of the tree. It's almost the same way as you move from the crust to the inner core of the earth. Okay, now let's leave the crust. You can see that this layer A1, A and B, that's the crust, and that's just more or less 10 centimeters, 10 kilometers of the earth. But remember that the earth goes almost up to 7,000, let me say 6,000 kilometers, and that's very, very deep. If we have to think of 6,000, to put this in context, 6,000 kilometers would be probably from Windhoek to Egypt, for example. Now think of that as a distance. So that's a very long distance. Now take that in the depth direction. That's how far the earth goes. Okay, now the mantle now is a layer that follows the crust, and that's what you can see, that it's part of two. This 2A and 2B, 2A being the outer part of the mantle, and then the 2B being the inner part. And for the purpose of time, I think I should rush up a bit. And then from the mantle, that we go to the core. The core, as you know, the core is just the center part. The core, even in any English speaking, is just the part that is the central part. So we have the outer core and the inner core. The inner core is what you call most of the center of gravity, and that's why, for example, if you are at a position of the earth that is close to the sea level. The sea level is what we think that when we say sea level, we are talking about the average elevation or where the sea is. When we say, for example, in Windhoek we are 1,700 kilometers above the sea level, we are saying that if you take a distance from here to Swakop, if you go to Wavis Bay, for example, if you go to Wavis Bay, for example, you have probably going to be 200 or 100 meters above the sea level, because they are so close to the sea. But at Windhoek here we are very, very elevated. So we are saying that the core is now that center of the earth. So what you need to know is to understand these three layers of the earth, from the crust to the mantle to the core, and also understanding what are the constituents, what does each part consist of, and the depth of that layer, and the temperature. That's very important when it comes to the understanding of the formation of the earth, and that is more or less the basis of geography. Understanding that can now help you understand all other things, weather, climate, vegetation, and all other things. So, but I would like to touch a little bit on the theory of Alfred Wegener. We know that in 1912, this is one of the German meteorologists who at some point thought that the earth was one continent. And even if you have to answer that question, it would depend. Now, if that assertion is true, can it be true that the earth was one continent, as called Pangea, and later it separated into Gondwana and the Russian and all those, and later into this continent that we see today? How can you, as a student, verify that? So you need to understand that the earth was continent. And can you, for example, use an evidence from biology about the fossil, about for example, similarity in vegetation? If for example, Southern Africa, you go to the west of Africa, let me say at the coast, and then you compare with the western side of North America, the area for Brazil and all other. Can you find, for example, similarity in vegetation, similarity in, for example, fossils or living organisms that live there? Then you can actually see that, okay, so this probably were together earlier. So any of that kind of justification can allow you to understand the theory of Alfred Wegener. But all in all, you also need to understand this theory and support it, whether you think it's true or not true. All right. We know that, especially centuries ago, the events of volcanoes, the events, the volcanic events were more than what we see now, but still in the areas where the earth is not stable, especially when you go in the area which has a lot of mountains and all that, you go to the area of East Asia, Indonesia, and all those Indonesia, those countries, China, Nepal, is that there's still a lot of volcanic activities going on. But the question is, we know that the immediate effect, which is more or less anybody can instantaneously say the volcanoes have bad effects, because of course they damage properties, the loss of lives, and even after events like tsunamis and all those things. But we also know that there could be some advantages. We know that the volcanoes make make soils fertile, and it even attract tourism, because most of the mountains and other things, these are caused by volcanic or earthquake events. Despite the wrong or the bad disadvantages it also have advantages. So familiarize yourself with these advantages and disadvantages. But why I put the third bullet in bold is because I want you to pay attention to the relationship between volcanoes, the current. These are the imaging, and that's very important. Like I said in the earlier part of the presentation, that you need to understand the relationship. You need to teach or to prepare the learners to face the current or the contemporary issues. So those who don't go to universities or go to vocational, they must at least be going to become innovators or to do anything in that area. The picture you see here is a 1991 volcanic eruption of Mount Pinatubo. Pinatubo now is this eruption happened in the Philippines. A few weeks after that eruption, there has been scientists, from atmospheric science point of view, scientists have noticed a cooler temperature around the area of that volcano. That means that if the Earth's atmosphere, for example, was 15 degrees Celsius, the area affected by that volcano was a bit cooler than that, with that average. Now we can see that, because we know that most of the volcanic eruption emit sulfur. Sulfur is a white gas, and you can also see that mostly here is a white thing, and you know that white reflect, it doesn't absorb. So if you have irradiation, or so it reflects instead of absorbing. There are now climate studies which are trying to see if a gas like sulfur can be used, because we know we are faced by the warming of the climate. So can we use gases like sulfur to cool the climate? And that's the essence of understanding the relationship between climate and these volcanic eruptions or volcanic activities. I always say that these things are always interrelated. The relationship between the lithosphere, the biosphere, the atmosphere, and the hydrosphere. These things are always interrelated. But look more in that direction, and probably get in touch with me, because we have to move on for the next few slides because of the time. The river processes and deltas and all formations like that. Okay, I would like to introduce to you that this Okavango Delta, most of you have known it. The Okavango Delta, it's being fed by the Okavango River, which originates from central Angola. We know that wherever you have rainfall and you have slope, then you have flow. So we have excess rainfall in central highlands of Angola, and then we have, because we are lying lower, so there's a slope between central Angola and northeast Namibia, and even as you proceed better lower to Botswana. And now we have Okavango Delta. Any delta actually is just to say that the place where the river, the mouth of the river ends, before reaching the mouth of the river would be the point where it reached the ocean. But if it didn't reach the ocean, that's what it says, it ends into a delta. So Okavango River didn't manage to reach the Indian Ocean. Instead, it formed a delta which is in Okavango, in Botswana. So what are the benefits of deltas? Are quite apart from being a water source. If you have to look at this, even on your Google Earth, whatever, you see that there's a town in Botswana called Maun, and that's one of the best tourist attraction place in Botswana. So we know that the attractions of tourism activities really depend on this delta, and then it supports also a lot of vegetation, it supports a lot of biodiversity in terms of animals and all that. So let's focus more. Read the Atlas of Namibia, read the Atlas of Africa. I'm getting to that so that you can understand and appreciate the need of the value of the river morphologies, and the result from the rivers, which is quite not only water sources as most of people perceive, but also other activities like supporting biodiversity and cooling the place and tourism activities and all that. Let's move on to flood. We for the past, this is an extract also from your module. For the past 3 years, since 2009, 2013, somewhere, we have extreme flooding events in the northern Namibia. What are the effects of floods? What are the man-made causes? Because we know that flooding is not necessarily a universal, it's not just only a natural, it's part of nature, yes, but what are the natural causes of floods, and what are the human-made causes of floods, and what are the effects? What you look on your screen here is the town of Oshakati. This is a few years ago, I think this was in 2012, and you can see that all these are the river channels or water channels, what we call Ishana, across Oshakati, Okatana, and all these things. So what are the effects of floods, and what are the causes of floods, and all that? So let's move to toward conclusion. What are the other priority areas that we need to pay attention to? Even if I don't have to go into details in this one because of time, we need to understand the weather and atmospheric processes, and that also refer back to what I have just alluded to about the atmospheric gases, what happened in the atmosphere, what happened, for example, if we burn. We need to appreciate when we burn biomass, when we burn trees, when we prepare our food for agriculture, all these gases are getting suspended in the atmosphere, and these affect our climate in a way that when you have radiation coming in from the sun, some can absorb that radiation, some can reflect it back, and so forth and so forth. In fact, it also affects the clouds and the atmospheric chemistry processes. But I would like you to pay attention to this book. If you cannot get it on your library, please contact me so that we can see if we can get if we can get it for you. It's a very important book for geography. It's called Geography Integrated Approach by David Waugh. I think it's 2009, but there might be even a better edition. This is the second edition that is in my that I use for most of this literature and all that. That's what I use also at university, but there could be a third edition that you might even be able to get. Atlas of Namibia by John Mendelsohn. That's very important for you to understand the national physical features. And also, I didn't put it here, but also the Atlas of Africa is very, very important. I have a copy of the Atlas of Africa. Please, if you can't have access to it, kindly let me know. To be final, we're just saying for any assignment or for any exam, please be punctual and be prepared. I have seen people who are sending me half-baked assignments because they probably just did it on the final day. Please try to have prepared assignments, and just for your own purposes, you can read the slide. Those are just common mistakes that we should always try to avoid. And Thank you very much. That's the end of the presentation. Please contact me. I think you have my email and my cell phone number. Contact me for more. Thank you very much.